Welcome to AI Newsbeat, the go-to source for the latest AI news and in-depth analysis. Today, we will have another crack at unraveling the mystery around Q-Star from OpenAI, including a look into OpenAI's research paper. Here's a quick recap. According to Reuters, OpenAI's secret breakthrough on artificial general intelligence, AGI, Q-Star precipitated the ousting of Sam Altman. Given vast computing resources, the new model was able to solve certain mathematical problems, making researchers very optimistic about Q-Star's future success. Before we continue, please smash the subscribe and like buttons below to ensure you are always up to date with the latest in the AI industry. A day before Sam was fired, he gave this chilling speech, "Is this a tool we've built or a creature we have built?" As per insiders, Q-Star is not just another incremental improvement, but a paradigm shift. It's rumored to have achieved something previously thought unattainable, a level of reasoning and generalization that propels it closer to AGI. This development allegedly sparked a wave of concern within OpenAI, leading to drastic measures, including the reshuffling of leadership and intensified debates on AI safety. Adding to the mystique of Q-Star is its supposed ability to generate synthetic data for training future AI models, a feat that challenges the very concept of machine learning as we know it. This ability hints at a self-perpetuating cycle of AI development, where AI is no longer bound by the limits of human-generated data. So what exactly is Q-Star? Some people have hypothesized that Q-Star is a search algorithm called A-star search built on top of Q-learning. Q-learning is a trial-and-error approach where a robot learns optimal actions in different situations by receiving rewards, while A-star search is a classic graph search algorithm. So what is being searched over? How is it done? It is searching over language, reasoning steps via tree of thoughts reasoning, linking LLM training and usage to the core components of deep RL that enabled success like AlphaGo, which is self-play, and look-ahead planning. Self-play for LLM would be like AI feedback, which will continuously improve itself. Look-ahead planning is the idea of using a model of the world such as LLM to reason into the future and produce better actions or outputs. To understand how all these come together, we need to cover recent results published from OpenAI and others that'll answer two questions. How do we construct a representation of language that we can search over, and construct meaningful language chunks rather than the entire completion? The answer lies in modular reasoning with LLMs via tree of thoughts prompting. Think step by step. Here's a graphical representation of a tree of thoughts prompting on LLMs. The beauty of this approach is that the chunking of reasoning steps allows for individual scoring to be applied to each of them. However, most LLMs today are fine-tuned using reinforced learning human feedback, RLHF, and relied on scoring of entire sequence of text response. This is where process reward models, PRM, comes to the rescue. The core idea is to assign a score to each step of the reasoning rather than a complete text message. To understand more, let's dive into OpenAI's paper titled, "Let's Verify Step by Step." In this paper, OpenAI concluded that based on their investigation, process supervision significantly outperforms outcome supervision for training models to solve problems from the challenging math dataset. The reward model performs best-of-n search over uniformly sampled solutions from the generator LLM. To collect process supervision data, human labelers were presented with step-by-step solutions to math problems sampled by LLM. PRM models were trained to predict the correctness of each step after the last token in each step. Two solutions to the same problem, graded by the PRM step by step. Green background indicates correct step, while red means wrong. Comparison of PRM versus outcome-supervised reward models evaluated by their ability to search over n-test solutions. Concluding that process supervision produced more reliable reward models than outcome supervision in the domain of mathematical reasoning. The links to these additional PRM resources would be presented in the description section below. The prompting from tree to thoughts gives diversity to the generations, which a policy can benefit from, with access to a PRM. The intricacies of this method involve collecting the right prompts, having a model to generate great reasoning steps, and most importantly, accurately scoring tens of thousands of completions. This last step is where the rumored vast computing resources use AI to label every step with a score instead of humans. Synthetic data is king, and with trees rather than single-width paths giving more and more options later on to arrive at the right answer. Thank you for tuning in and hope to see you again.